When we use the factor by grouping strategy, we're going to look at two distinct different groups. In this case, we'll look at the first two terms of this polynomial, and then we'll look at the second two. It's our hope that when we factor each group individually, that we're going to find a common factor. So let's take a look at the first group, or the binomial underlined in blue. We're going to look for a greatest common factor. And what I notice is the coefficients are 3 and 6. 3 goes into both 3 and 6. This makes this the greatest common factor of the coefficients. Next, we'll look at the variable, x squared and x. The greatest thing they have in common is a single x. When we take a 3x out of the first term, or divide by 3x, the 3's cancel out. X squared over x leaves us a single x. Next, when we take the second term, 6x, and divide by 3x, 6 divided by 3 is a positive 2, and x over x cancel out. Now we'll move on to the second group, negative 4x minus 8. Notice I'm going to keep the negative sign with the term minus 4x. When I look for a greatest common factor between the coefficients, 4 and 8, the greatest number I can divide into both is negative 4. There is no common factor between variables, as the first one has an x and the second has no variable. So we'll divide both terms by negative 4. Negative 4x divided by negative 4 leaves us just a plain x. Negative 4 divided by negative 8 leaves us a positive 2. What you'll notice, and what was the goal, is that we've created a common factor in both of them, x plus 2. And we can now factor that out, or take it out of each term, writing it in front, and write down what's left. When we take the x plus 2 out of the first term, we're left with 3x. When we take the x plus 2 out of the second term, we're left with negative 4. This is the factored form of our original polynomial. You could always FOIL this back out if you were unsure to check, and you should get the original polynomial term.